So there's reducing fractions and rational expressions. What's the next topic usually? Multiplying. Why multiplying? Because it's the same as reducing. Let's say we have 14/15 times 2/35. So the 14 and the 2 are up top, and the 15 and the 35 are on the bottom. We might be tempted to say 14 times 2, that's 28. 15 times 35. Eesh. Can't do that in my head. Go off here, do the arithmetic, get your big number, and then try to find common factors here. What a waste of time. Right? It's already factored for us. 14 times 2 is 28. That means 28 is 14 times 2. 14 is 7 times 2. And 2 is already a prime number. 15, that's 5 times 3. 5 won't cancel, 3 won't cancel. So I'll just leave that as 15. But 35, 7 and 5, what do you know? Goodbye sevens. So we're left with 2 times 2 over 15 times 5. Who thinks that's a good final answer? Of course not. We want to finish simplifying. 2 times 2 is 4. 15 times 5 is 75. That is our final answer. It's no different if we go from numbers to monomials. So 14x squared over 15yz times 2 over 35 xy squared. Let's see what you get here. So 14 x squared and 2, 15 yz and 35 xy squared. See what you can cancel there. I'll give you a minute. Okay, so just like with numbers, I've got 7 and 2. And 15 is not going to help me anywhere else, so I'll just keep that as 15. See, times 7 and 5. And I'm canceling 1x with 1x, 7 with 7. That's it. So 2 times 2 times x. Over 15 times 5 times 3y's and 1z. So 4x over 75 y cubed z. Right, 3y's here. 1, 2, 3. Now, as we get good at this, maybe some of you were able to jump straight here. See how we could do that right away. Recognize 35 is 5 times 7. 14 is 2 times 7, so 7's gone. I've got 2 x's up here. One of those goes away because it cancels here. 2 and 2, there's my 4x. 15 times 5, that's my 75. And 1, 2, 3 y's, boom. Right? We can get fast at this with monomials, just like some of you are fast here canceling with numbers. It's hard to be fast with rational expressions, but we can still see how the process works the same way. So let's keep with black. That seems more formal here. Let's try x squared plus x minus 6 over x squared plus 10x plus 25 times x squared plus 6x plus 5 over 42x minus 84. Now people are often tempted, x squared cancel. No way. Right, this x squared is one term among 3 contained within this whole factor. If I'm going to cancel anything, it's got to be a factor, right? 7 times. I have to write this as things being multiplied over other things being multiplied. So first things first, x squared plus x minus 6. X squared, that's going to be x and x. Negative 6 sounds familiar, like the last problem. I'm going to have 3 and 2. One's positive, the other's negative. To get positive 1, we're going to want plus 3 and minus 2. X squared plus 6x plus 5. Let's see, to get x squared, that's going to be x and x. To get 5, it's got to be 5 and 1. Positive 5, it's got to be the same signs here. If it adds up to positive 6, they're both positive. There's my numerator as 4 factors, each one a binomial. Numerator, x squared, 25, I'm thinking perfect square trinomial. Let's see, if it's x squared, it's going to be x and x. 25 might be 1 and 25, but that won't give me 10, right? It's probably going to be 5 and 5. 5 squared is 25. If I double 5, 5x and 5x, there's my 10x. Positive, so it's positive. All right. Now 42x minus 84. I only have 2 terms here. This isn't a trinomial quadratic. It's just 2 terms, but they have a 42 in common. So I just have 42 by itself, monomial. This is 42 times x. This is 42 times 2. It's minus, so it's minus. Now I can look to cancel. 42 is my only coefficient. I don't have any number coefficients here, right? There's no number being multiplied by all these binomials. So 42 is going to stay put. But I've got x minus 2 and x minus 2. I've got x plus 5 and x plus 5. X plus 3, nope. X plus 1, nope. So we've canceled as much as we can cancel. So our next line, x plus 3 and x plus 1 at the top, and x plus 5 and 42 on the bottom. Do we leave our answer as a product divided by another product? Of course not. We multiplied. Same thing here. This is not our final answer. The computer may accept that, but that's sloppy and lazy. We simplify with no parentheses. X times x, outer 1x, inner 3x, 1x plus 3x, and last 3 times 1, 3. The more you multiply binomials, the faster you can get. The more you can jump straight to your answer without having to do the 4-term intermediary step. Down here, we're just distributing 42. 42x plus 42 times 5, 210. And that is our answer.